Hello and welcome to this lecture video on the uses of research. After this lesson, students should be able to recognize the advantages of scientific research over other forms of knowledge, including knowledge from authority and knowledge from personal inquiry. You should be able to distinguish between basic and applied research and understand the differences between the four purposes of scientific research: exploration, description, explanation, and evaluation. Before we start talking about knowledge from scientific research, let's talk about knowledge from two other sources. The first is knowledge from authorities. This is the sort of knowledge we get from figures of authority, such as doctors, lawyers, politicians, scientists, and our parents. This form of knowledge has many benefits, including the fact that we don't have time to necessarily research every decision we have to make, and so we end up placing some of our trust in people like doctors, lawyers, scientists, and our parents, who tend to have more knowledge and expertise than us, particularly in the fields of, say, medicine, right? The law, science. And so we tend to rely on these figures of authority for some of our knowledge. However, the downside here is that we may be putting too much trust into these figures of authority, or we might be putting our trust into the wrong sorts of authority or expertise, which might lead to us making incorrect, misleading, or inappropriate conclusions or decisions. We also have knowledge from personal inquiry. This is the knowledge that we've gained from our own personal experience and inquiry. This is good because we make a lot of our decisions based on our past, based on what we've experienced in the past, such as touching a hot stove and realizing, ouch, that hurt, we shouldn't do that again. It's good knowledge to have. We don't need to continue testing to see if the stove is hot to know that touching it hurts. The problem with this is that we tend to overgeneralize and perceive things from only our perspective, and we have a hard time opening up and understanding other perspectives. So we might tend to overgeneralize about a particular group of people or a particular event, which then leads us to only seeing those events in a negative light or those people in a negative light, and closing off further experiences around those people or events. Knowledge from scientific research promotes skepticism about the knowledge it generates. In contrast to a lot of the knowledge from authorities or knowledge from personal inquiry, one of the goals of scientific research is to doubt what we are seeing, to be skeptical about what is happening, and to test and retest it to make sure. It also promotes communication, including publishing, among a community of scholars. Not only are we going to go out and test our ideas and our theories over and over again, but we're then going to communicate or publish those results to other people. And so this ends up involving a systematic testing of our ideas or hypotheses through the collection of data, testing that data against our hypothesis, coming up with a conclusion, communicating that conclusion, and then perhaps going back and retesting and retesting and retesting. We are going to use empirical observation to collect data. So we're going to be able to observe it in some fashion or measure it in some fashion. And we're going to use logic and reasoning to evaluate our theories and hypotheses against the collection of our data. Scientific research does not address questions about values, morals, existence, philosophy. These are not scientific since we can't empirically measure them. So, for example, we can ask questions from a scientific perspective around how many immigrants are coming to this country, what are the effect of immigrants on our economy, how much does it cost for an immigrant to come. Those are all questions we can answer with scientific research because we can go out and measure those things. What we can't answer with scientific research are things like, should we let more immigrants into this country? Should we close our borders? Because those are questions about our values and morals as a country, not about things that we can empirically measure. So what is the scientific method? The scientific method is a way of conducting empirical research following rules that specify our objectivity, logic, and communication among a community of knowledge seekers and the connection between research and theory. This sort of process of coming up with a theory, a hypothesis from that theory, going out and collecting data and testing that data while assuming some sort of objectivity and logic is what is called a positivist view of science. And this is the idea that human knowledge must be based on what can be perceived and that we can be objective about the world around us, and that whatever we find through this scientific process, as long as we are objective, is the real truth, is reality. Now, this has been the main kind of view of scientists for a very long time. But recently, and I say recently meaning the last 50 or so years, there's been a push toward a post-positivist view of science that argues that knowledge is not based on irrefutable observable grounds, and that it is always biased by the perspective of the scientist. And this post-positivist view is saying that we are all biased. No matter how hard we try, we are going to be biased. That's because the sort of questions we decide to ask, the sort of research we decide to employ, are all going to be based on our own personal opinions and ideas, and therefore biased. So the starting point, asking a question, is a starting point where we are already introducing bias. And so we can't be sure that what we are seeing is actual reality because our inherent starting point is a starting point of bias. And this isn't to say that post-positivists don't think it's worthwhile being objective. No, what they're saying is that we can't be fully objective, so it's best to try to create what they call intersubjectivity, where we approach a question from our own perspective, other people approach that same question or same idea from their perspectives, and we see where we agree and we see where we disagree. This sort of intersubjectivity, or agreements about reality that result from comparing our observations to that of one another, can start to establish what is a reality and what isn't. And so for the post-positivist, science can still provide a relatively solid base for speculation, but we also need to be more aware of where we are coming from as scientists and the biases that we are bringing with us. Alright, so let's take a quick look at the scientific process. You've probably seen this before in other classes, but we're going to kind of review it anyway. So with the scientific process, we generally are going to start with a theory, which are a systematic explanation for what we are seeing for underlying behaviors or phenomena. These theories are trying to explain what is happening. From those theories, we try to derive a hypothesis, which details a specific relationship between two or more variables as suggested by our theory. We then go out and collect data in the form of observations that we're collecting in order to test that hypothesis and subsequently the theory. And as part of collecting this data, we are looking for patterns of behavior or empirical generalizations. These are called laws. These are the sort of patterns we see when we look at the data. Scientific research in this way relies on logic, which is the theories and hypotheses that are generated from those theories, and evidence, which is the data and empirical generalizations or laws, in order to create scientific knowledge. So if we think about it in this circular pattern here, we might start with saying, oh, it looks like there's a pattern going on. What things might explain that pattern? Okay, well, if my explanation of these patterns is correct based on my theory, then I should be able to test it with this hypothesis and collecting data. If I'm right, I should see that the data matches my hypothesis, which is then going to help confirm my theory. But if I'm wrong, maybe I need to go look at different patterns, come up with new theories, new hypotheses, and recollect my data. Scientific research can be broken down into basically 4 types. The first is basic research, with 2 subcategories here. Basic research is research that's just designed to add to our fundamental understanding and knowledge about the social world. This can be divided up into exploratory research, which is research that tends to be groundbreaking on a relatively unstudied topic or a new area of research. This tends to be qualitative in that we're not necessarily coming up with numbers, but just trying to describe in words what is going on. And we also have descriptive research, which is research designed to describe groups, activities, situations, or events. This can be qualitative or quantitative. So one is more exploratory, trying to get at new ideas, new information, relatively unstudied topics. That's going to be our exploratory research. In descriptive research, we may already know something about it, but we're just trying to come up with some basic descriptions that can appropriately describe whatever it is we want to look at. Next, we have applied research. Applied research, again, can be divided into two subcategories, but applied research is research that's intended to be useful in the immediate future and to suggest a course of action or increase the effectiveness in some area. So here we're actually trying to explain or solve a problem. So the first here is an explanatory research. This is research that's designed to explain why something happens, why subjects vary in one way or another. We're trying to answer a why question. Evaluation research is research that's designed to assess the impacts or effectiveness of a particular program, policy, or law. So we want to know if a particular law is effective. We're going to do some sort of evaluation research, to see if it is effective. All right, that's all we have for this lecture video. Thank you very much.